In this video of Florida Man Math, we're taking a look at a question from the r/cheatatmathhomework subreddit. So the question is, find the arc length of the curve y is equal to x to the 9 over 18 plus 1 over 14x to the 7th on the interval 3 less than or equal to x less than or equal to 9. So we should recall that the formula for arc length, when given a function y, is the integral from a to b over the lower and upper limits. So in this case, 3 and 9 would be a and b respectively. And it's the square root of 1 plus, now this is the quantity dy dx being squared and integrated with respect to x. So all we really need to do is just find this term, square it, add 1, take the square root, and then integrate. So let's do that. So we've got y is equal to 1 over 18, x to the 9, plus 1 over 14. I'm going to rewrite x to the 7th in the denominator as x to the minus 7 in the numerator. So what we need to do is find dy dx. Taking the derivative with respect to x on both sides, we have 9 over 18, x to the 8th, plus minus 7 comes down, so it's really a minus 7 over 14, x to the minus 7 gets decremented by 1, minus 8. So let's clean this up a bit before squaring. 9 over 18 cancels out to give you 1/2, x to the 8. Minus 7 over 14 also reduces to minus 1/2, x to the minus 8. So by itself, this is an acceptable form of dy dx, but you can also present it like this. Let's factor out the 1/2 times x to the 8th minus 1 over x to the 8th. And for reasons that'll become clear later, it's actually easier to combine this into a single fraction. So let's get a common denominator. Basically need to multiply by x to the 8th in both top and bottom here. So we're left with 1 over 2 times x to the 16 minus that 1 all over x to the 8th. All right, so this is dy dx. But from our formula up top, we need the quantity dy dx all squared. So let's compute that here. So dy dx quantity squared is equal to the square of this thing. So the 1/2 being squared turns into 1/4. And then x to the 16 minus 1 gets squared like that. All over x to the 8th being squared is x to the 16th. Okay, so in our formula now, we just need to add 1. We're just building this up as we go along. 1 plus the quantity dy dx squared. So this is just 1 plus this entire term. So we can literally copy and paste that. So let's try to get this into a single fraction. It'll be easier to take the square root. So this is 1/4 times all that. So the common denominator is 4x to the 16. So this will be 4x to the 16 plus 1 times that. And let's just distribute this. Let's FOIL it out. This will be x to the 32 minus 2x to the 16 plus 1 all over 4x to the 16. Some of these terms will cancel out. So 4x to the 16 minus 2x to the 16. And let's rewrite it in descending order. X to the 32 plus 2 x to the 16 plus 1 all over 4x to the 16. And one last step, we recognize that this is quadratic in the term x to the 16th. So we can rewrite it as x to the 16th plus 1 quantity squared all over 4x to the 16th. And so this represents, again, 1 plus the quantity dy dx squared. Going way back up, now we're in a position to take the square root. So let's do that now. Taking the square root of this side, and that leaves us with this numerator that cancels out here. So that's just x to the 16th plus 1 divided by the square root of 4 times x to the 16th. It's just 2 x to the 8th. And so all we need to do now is integrate this, and we've got our formula for arc length. Now we're integrating with respect to x for between x equals 3 and 9, so we just need to apply those limits. And this is just a straightforward polynomial. So how does it condense down? So this is the integral from 3 to 9 of, we can factor out this 2 right away, so 1/2. And then x to the 16th over x to the 8th, it's just x to the 8th, plus x to the minus 8 dx. So we've got our polynomial, and this is just straightforward for reducing the powers of x raised to 8 and minus 8. So the integral evaluated is 1/9 x to the 9th minus 1 over 7 x to the minus 7. And this is the limits from 3 to 9. So at this point, to get this down to a single fraction, we just need to plug and chug for the fundamental theorem of calculus. So 1/2 times the first part, so this is 1/9, 9 to the 9th, minus 1/7 times 9 to the minus 7. And then subtract 1/9, 3 to the 9th, minus 1/7 times 3 to the minus 7. Okay, so some of this reduces down. So notice here that 1 divided by 9 times 9 to the 9 is basically 9 to the 9 over 9. So this reduces the exponent there. So the first term here would be 9 to the 8th. And we really can't simplify this by much. So we'll leave that as 1 over 7 times 9 to the 7th. And then 3 to the 9 over 9 is the same thing as 3 to the 9 over 3 squared. So we can just rewrite that as 3 to the 7th. And then there's not much to do for this one. So we'll put in the denominator. And this 1/2 is still being multiplied by the entire difference here. So how does this reduce down? 1/2 times, if we get a common denominator here, we also might consider getting this in a power of 3. That way it's all just powers of 3 floating around. So 9 to the 8th is 3 squared to the 8th, which is 3 to the 16th. Similarly, 9 to the 7th would be 3 squared to the 7th. So this is 7 times 3 to the 14th. Minus 3 to the 7th. I guess we can carry that minus the way through, so minus 3 to the 7th, and then distributing here. Get plus 1 over 7, 3 to the 7th. All right. So lots of powers of 3 floating around, but that's okay. 1/2 times the big quantity. So our common denominator here looks to be 7 times 3 to the 14th. So let's just adjust everything to account for that. So we need 7 times 3 to the 14 and need to adjust. This has already got that denominator there. Same deal here. 7 times 3 to the 14. And this one is almost all the way there. It has the 7, it has half of the 3's, but we need to give it 7 more 3's. So, altogether, we have 7 times 3 to the 14 times 3 to the 16. That's 7 times 3 to the 30. Minus 1 from here. Minus 7 times 3 to the 21 plus 3 to the 7 all over 7 times 3 to the 14th as the common denominator. So at this point, we just could get this 2 factored in the denominator, and let's see. Yeah, we'll just rearrange the powers of 3 so it looks a bit nicer. So 7 times 3 to the 30 minus 7 times 3 to the 21 plus 3 to the 7th minus 1 all over 2 times 7 times 3 to the 14th. And at this point, there's a couple of things you could factor out, but it really doesn't change much about actually having to compute this fraction. So we're in a position to declare the answer that the arc length for that formula is this fraction. 7 times 3 to the 30th minus 7 times 3 to the 21st plus 3 to the 7th minus 1 all over 2 by 7 by 3 to the 14th. Alright, if you liked this video or learned something from it, please consider subscribing to Florida Man Math, and as always, thank you for watching.